Hi everybody, in this video we're going to be talking about simplifying given trigonometric expressions. So before we actually try simplifying trig expressions, let's talk about what that means. So the definition of to simplify trigonometric expression means to rewrite it as a numerical expression or in terms of a single trigonometric function. Identities are useful in simplifying trigonometric expressions. We're going to be doing a lot of substituting. We're going to be really using our rules of algebra to try to make things look as simple as possible. So some strategies, things you want to think about trying to do in order to break down these expressions. Rewrite using reciprocal and quotient identities. So we've been doing that for the last little bit, where we're going to take cosecant and substitute in 1 over sine, or we're going to know that tan is equal to sine over cosine. So those things you want to think about being able to rewrite. Look for Pythagorean identities or a possible way to create one. If you can find sine squared plus cosine squared in an expression, you get to take those out. Take that whole thing out, sine squared plus cosine squared, and substitute in 1 because those are the same. So think about those Pythagorean identities, because if we can get, two squared expressions out of an equation and just put in a number 1, we're going to be in a lot better shape. Number 3, combine fractions using a common denominator. So if you are struggling a little bit with fractions, we're going to be using them a lot. We're going to have to create fractions that we can add and subtract, which means we're going to have to create common denominators. So keep that in mind as we're going forward. We're going to be doing a lot of work with fractions. We're also going to be breaking fractions apart. And we're going back to factoring. So all these rules we've practiced along the way, don't forget about difference of squares or looking for things that you can factor out, terms that have the same variable or expression in it. So all of those different things are going to be ways that we are going to try to simplify some trig expressions. So in this video on the note sheet, I'm going to step you through questions 1 through 6, and then I would like for you to try 7 through the rest of them, 7 through 12 on your own. Again, I don't expect you guys to be experts at these off the bat, but the more you do, the more familiar you're going to be with ways that you can simplify expressions, and therefore it's just going to get easier. It's really one of those, the more you practice, the better off you're going to be. So let's start with number 1. In number 1, it says that the secant of theta minus sine of theta times tan of theta. So what we want to do is to be able to simplify this into maybe one trig expression or maybe one number. So the first thing we're going to do, if you're not sure where to go, you can start by taking all of those expressions and turning them into sines and cosines. Okay, so let's start with that. So the secant of theta, I'm going to rewrite as 1 over cosine of theta minus sine of theta. I'm just going to write that as a fraction over 1, because if I've got one fraction, I'm probably going to have to deal with multiple, times tangent, we know, is sine over cosine. So I just started by taking this first expression and rewriting everything in terms of sine and cosine. Okay, so I see here that I'm going to be multiplying the two fractions on the right. So let's make that my next step. I'm going to leave the 1 over cosine of theta by itself, and then I'm going to multiply the two fractions on the right. Order of operations as I do that first anyway. So sine times sine is sine squared theta over cosine theta. Now what's worked out nicely here is now I've got two fractions that I'm subtracting. So what I can do, since they have the same denominator, I don't have to create common denominators. I can just put these two fractions together. It's great. So I'm going to rewrite this as one fraction. So this is now equal to 1 minus sine squared theta over cosine of theta. Now, whenever we see a 1 and a squared sine or cosine or tangent or secant or cotangent or cosecant, we really want to remember those Pythagorean identities. So the one that has to do with sine is I've got sine squared theta plus cosine squared theta equals 1. If I rearrange that, I can find that the cosine squared of theta is equal to 1 minus the sine squared of theta. So you're going to have to get really familiar with all those different iterations that I talked about in the last video. So here's 1 minus sine squared theta, which is what we have in this fraction. So to try to simplify this further, I can actually, instead of saying 1 minus sine squared theta, I can substitute in for it cosine squared theta because they mean the same thing. They're equal to the same thing. So now this is cosine squared theta over cosine of theta. Now don't forget when we write cosine squared of theta, what that really is that it's the cosine of theta squared. So really, in the numerator here, I have the cosine of theta times the cosine of theta over cosine of theta. Since those are being multiplied, I can cancel out the cosine in the numerator with the cosine in the denominator. You don't have to write out this step. If you recognize that the cosine squared theta is cosine times itself, you could actually do it in the step before, which is often what I'll do. That I know I've got 2 cosine thetas in the numerator, I've got 1 cosine theta in the denominator, so I'm going to be left with 1 in the numerator. So what this whole thing is actually equal to, I just put that this is kind of a side note, put that in parentheses. This whole expression, once I cancel out the cosines, the whole thing is actually equal to the cosine of theta. That is my most simplified answer. That's my final answer for this problem. So by going through all those steps, changing everything into sine and cosine, combining like terms, creating common denominators so I can add and subtract fractions. Those are all steps that we're going to take so that we can get to the most simplified version of that expression. So number 2 is going to be very similar to number 1. I'm going to rewrite all of these terms in terms of sine and cosine. So I'm going to start with that the sine of A, I'm going to bring that down, plus, I'm going to put this over 1, cosine of A over 1, times tangent we can rewrite as sine of A over cosine of A. So what's nice here is since we're going to multiply these first, order of operations says we'll multiply first, the cosine in the numerator is automatically going to cancel with the cosine in the denominator. So now if we rewrite this expression, we actually don't even need the fractions anymore. We now have the sine of A plus the sine of A. Well, just like if we were to have x plus x is actually equal to 2x, we're going to do the same thing. We have 2 sine of a's. They're exactly the same thing. So I can rewrite that it's 2 times the sine of a. And that's my final answer. So not too bad. All right, so these look a little bit different. Cotan squared of u minus cosecant squared of u, because we don't use these reciprocal functions quite as much. So instead of working with the reciprocal functions that we're not quite as familiar with, let's turn all of this in terms of sine and cosine. So we know that tangent is sine over cosine, so cotangent is going to be cosine over sine. So cotan squared of u is actually the cosine squared of u over the sine squared of u. Now, if that's a little off to you, what you could say is that this is really the cotan of u squared, which is equal to cosine of u over sine of u squared. And then we would multiply it by itself. So that's where that cosine squared of u over sine squared of u comes from. But you can skip right to this step. So cotan squared of u simplifies to cosine squared of u over sine squared of u. And then cosecant is just 1 over sine squared of u. Really nice here. We do have 2 fractions that we're subtracting, but we already have that common denominator, so we don't have to change that. So we're going to end up with the cosine squared of u minus 1 over sine squared of u. Okay, now here we've got cosine squared and a minus 1. So this should really set off those alarm bells in your head that you're thinking about those Pythagorean identities. So the one that has to do with cosine and sine, or cosine squared, is we've got sine squared of, I'm just going to use theta, plus cosine squared of theta equals 1. So what I want to end up with is this cosine squared minus 1. So to do that, I'm going to move the 1 to this side. So I've got sine squared theta plus cosine squared theta minus 1 equals 0. What I'm looking for is just this cosine squared of theta minus 1, so I'm going to move the sine squared over to the other side. So that leaves me with that the cosine squared of theta minus 1 equals negative sine squared of theta. Okay, because I'm going to subtract sine squared theta from both sides. So now I can substitute in negative sine squared theta for the cosine squared of theta minus 1, which is what we have, or cosine u minus 1. So this is the same as negative sine squared u over sine squared u. These are exactly the same. There's two sine u's on the top with two sine u's on the bottom. When those cancel out, I'm left with a 1, but don't forget about this negative out in front. So my final answer for this is actually negative 1. This is one of those problems where all of the trig functions end up canceling out, and our final answer is just a number. Number 4 starts with our problem already in a fraction. So our experience so far is that we may have to create fractions when we use the reciprocal functions, but really at the end of the day, we don't want fractions as our final answer. So I like to look at a problem before I jump too far into it to see what I notice. So what I'm seeing is that inside the parentheses here, I'm going to be dealing with tangent and cotangent. Okay, those are similar, right? Reciprocal functions of one another. So I want to keep that in mind. What I see outside of that is that I have sine over cosine. Now, the sine is being multiplied times the set of parentheses. Technically, that's multiplication. So technically, I could cancel or I can separate here. So what I'm actually going to redo here, sine over cosine is tangent, right? So we've got something going on there. We've got the tangent and cotangent in the parentheses. And if we separate this fraction a little bit, if we just have the sine over the cosine, we also have tangent. So here's where you're going to start to see, okay, I see tangent, but I also see tangent and cotangent. How can I separate? So what I'm going to do is I'm going to rewrite this, that I have the sine of x over the cosine of x times this parentheses, tan of x plus cotan of x. Now remember, these are actually over 1. So if I were to multiply this back through, I would multiply the sine times the set of parentheses and then the cosine times the 1. So we can get back to where we started. All I did was separate the pieces that were being multiplied. Okay, so make this a little bit smaller. Get rid of these extra pieces. So for right now, I have the sine of x over the cosine of x times that set of parentheses. So now what I'm going to do is I'm going to say sine of x over cosine of x is actually tangent of x times tangent of x plus cotan of x. Okay, now I'm going to distribute. When I multiply tangent times tangent, I'm going to get tan squared x plus, now let's look at this over on the side. When I multiply tan of x times the cotan of x, what I'm doing is tan of x over 1 times 1 over tan of x. So when I multiply a trig function times its reciprocal, I end up canceling out both of the trig functions. So tangent of x times cotangent of x is just 1. So when I do this second distribution here, tan times cotan, I'm left with 1. Now if I go back to the trig identities, if I use that Pythagorean identity, tan squared of x plus 1 is actually just equal to secant squared of x. And that's going to be your final answer. We've reduced this down to one trig function. We're better off with a reciprocal function instead of 1 over cosine. We would rather represent this function as the reciprocal function rather than the normal trig function with a fraction involved. So this secant squared x is going to be your final answer. Number 5 is the first problem we've had where we have one term that is not a fraction, one term that is a fraction, and unfortunately, based on what we've been given, we can't combine them yet. In order to subtract these, because that's the operations indicated in between, we need common denominators. Well, the common denominator is going to be this over cosecant. This is the denominator we need to use. So to have this first term have a denominator of cosecant, which is what we need, I need to multiply this by cosecant of theta, over cosecant of theta. What I'm really multiplying by is an equivalent of 1. Cosecant over cosecant, it would cancel each other out. That's 1. So I'm going to change what that first fraction looks like, but I'm not, or sorry, the first term, but I'm not changing what it means. So let me rewrite this over here. So I've got cosecant of theta minus cotan squared of theta over cosecant of theta. So what I'm going to do is I'm going to multiply the first term by the cosecant of theta over the cosecant of theta. Now, that's equal to 1 because it's the same term over itself. So what I have now, when I multiply cosecant times cosecant, and this is over 1, I end up with cosecant squared of theta, and then cosecant times 1 over just cosecant of theta. If I were to simplify this and cancel out, then I'm back to where I started. I would simplify down to cosecant of theta. So hopefully that makes sense. Then I'm going to rewrite the rest. Minus cotan squared of theta over cosecant of theta. So now it's great. I have common denominators. So now I can put these two things together. So now I have the cosecant squared of theta minus the cotan of theta, squared of theta, over cosecant of theta. Go back to the Pythagorean identity, cosecant squared theta minus cotangent squared theta is just equal to 1. It's awesome. We can just get rid of it. So it's not the way we're given that Pythagorean identity. What we often see is that the cotangent squared of theta plus 1 equals the cosecant squared of theta. But if we subtract cotan squared theta from both sides, we're going to find that 1 is equal to cosecant squared theta minus cotan squared theta. That's where that 1 comes from. So instead of having this big long, or the two terms, the two bigger messy terms, instead of having that, I can substitute 1 in for them. So now what I have is that 1, this whole thing is equal to 1 over cosecant theta. Well, cosecant theta is just 1 over sine theta, which means the final answer is just the sine of theta. That's my most simplified answer. All right, the last problem for this video, we have a fraction where we have 2 terms in the numerator and 1 term in the denominator. So when I teach my Algebra 1 kids about fractions and we talk about slope, it's where we often talk about slope. When you have 2 terms in the numerator, we can actually separate this fraction out. And I do it in a way that I call beans. So what I can do here is I can create a bean on the left that I give my numerator the denominator, or I give the first part of my numerator the denominator, and I'm going to create a second bean on the right. So what I need to do is I'm going to separate this fraction into 2 fractions, but I'm going to give the numerator, both parts of the numerator, that same denominator. So I'm going to rewrite this. My green bean on the left says that I'm going to have the cosecant of beta over the cosecant of beta. That's my green bean. The denominator goes with the part on the left. My yellow bean is I'm going to give the denominator to the part on the right. So this is still minus sine of beta over cosecant of beta. Now I can simplify. So the hard part here was the separating, or not the hard part, but the algebra part was separating the fraction. So now cosecant of beta over cosecant of beta is just 1 minus. So here I've got sine of beta over cosecant of beta. So what that really is the sine of beta over 1 over sine of beta, which is really sine of beta over 1 times, keep, change, flip. So I keep the sine of beta and change division and multiplication, and then I flip the second fraction. So what I'm really going to have here is sine squared beta. Okay, so if you're not sure about that, go ahead and check that out again. But this cosecant essentially comes up to the top as another sine. So what I have is 1 minus sine squared beta. If we go back to our trig identity, let me start the other way, sine of squared of theta plus cosine squared of theta equals 1. Well, if I subtract sine squared of theta from both sides, I have that the cosine squared of theta equals 1 minus sine squared theta. This is exactly the same as what I have here. So instead of having the two terms, I can replace it with one. So I'm going to end up having that this whole thing is equal to the cosine squared of beta. And that's going to be my final, most simplified answer. So there are 6 problems to get you guys started. Again, problems or worksheets like this, they certainly get more complicated as they go, but you're going to be approaching these problems the same way. Look for factoring, look for common denominators, try to find those Pythagorean identities as much as you can. It's going to be super helpful. So from here, go ahead and try number 7 through 12 on the same worksheet and see how you can do. Please be in touch with me all week. We can go through any questions that you just might need a little kind of help with direction on which way to go. I'm around. Again, I'm not expecting you to be experts yet, so just give it a try and let's see where you can go with it. Good luck and reach out with any questions.